In my last video, I discussed my fears about getting a heat pump from Octopus Energy. Well, they've recently been around to do a heat pump survey, and in that I learned about some hidden costs that I weren't aware of. These hidden costs are really important because they're going to be responsible for you to do and for you to pay for, and they're not included in the Octopus fixed price. I also learned some stuff about heat pump locations. The locations I thought were perfect for it are not perfect for it, and also we've learned some information about the Cosy6, including how it works, but more importantly, how long you'd have to wait if you do specifically want a Cosy6. Now, my engineer Aaron was a little bit camera shy, so I haven't really got any footage of him going around, but I can very easily explain what happened because I took detailed notes as he was doing it. Now, they obviously want to know if you've got a storage tank already, hot water storage. I haven't. I'm on a combi system, so I need a location for that tank, so they needed to work out where that tank was going, so that was part of the first part of the discussion. Then they need to know, where do you think you're going to put the outside unit for the heat pump? So I had some locations in mind that I thought were perfect, and this is where the main bulk of this video will go near the end, because the location I thought was great, we changed and then we changed again, and it had to keep adapting all the way through the survey. Now, if you saw my last video, I talked about how I want a Cosy6 heat pump. The Cosy6 is going to be the very first in-house design heat pump from Octopus Energy. Octopus Energy bought out a company called Red Heat Pumps, and now they make the Cosy6. The Cosy6 is a completely different looking heat pump, but it also uses different gas. It uses propane gas instead of the regular R1234YR gas. I don't know if that's the right letters at the end, we'll get to that later, but instead of using hydrocarbons, it uses a propane gas that is basically a lot cheaper to make, but it also can get higher temperatures. These propane systems can hit 80°C, so it could be a direct gas replacement boiler for people in the future who can't have a can't have gas boilers anymore, or just want to move away from gas. So it uses propane gas to get the heat in there, and we're going to be doing some more videos around that. And also there's another video to follow before an install. There's also going to be another video about the telephone call that Octopus Energy will go through the survey results with me. Now, if you want to follow my journey of getting a heat pump, follow my journey about understanding about the propane Cosy6, then make sure you go and click that subscribe button on this video, and also don't forget to click that notification bell because you might miss one of the next videos. Now, they're going to come around and create the most detailed floor plan of your house that you would ever think was imaginable. They're going to measure every single inch of your house. Every single room needs to be measured. Utility rooms, everything, so they can get the most detailed floor plan. They're then going to measure every single window in those rooms and every single doorway and every single door. This is so they can get the best heat loss calculation they can and get everything into that tablet of theirs. They're also going to take some very detailed measurements of your radiators, so they know what size radiator, what type of radiator it is, so they also know what heat output that radiator's got. This is where they'll work out later on in the video if it's sufficient and if that radiator is fine or needs changing. They're also, because I've got Microbore pipe, they may take a measurement of your pipes. We're going to get into this later in the video because Microbore causes some real challenges for the heat pump engineer surveyor, and we're going to explain what they are in this video. Now, once they've got this detailed plan, the surveyor should go through on his tablet with you what the design temperature is for each room for what he's measured. And this is very important that you go into this because you may want to slightly change the design temperature for certain rooms if you use them in certain different uses. Now, I'm going to go through what the design temperature is and explain what that actually means, because MCS have different set of rules around what a temperature a certain room should get to as a bare minimum. So if I give you an idea, bathrooms are 22°C. They're usually the warmest rooms of the house because it tends to be where we're wearing the least amount of clothes. Dining rooms and en suites are 21°C because obviously, you know, still fairly comfortable, sort of not wearing jumpers in your dining room. And then your entrance halls, kitchens and landings and utility rooms and downstairs toilets and bedrooms are all at 18°C. So people prefer to sleep in a colder room. 18°C is considered sort of the temperature that your bedroom should be. Now, I have some of my bedrooms as offices, which is what I'm in here now. One of the bedrooms is my son's room, who's a small child. We're hoping to have another child later on, so obviously another small child, so nursery. So I've got a couple of rooms that are dedicated to basically other uses. So I asked them to change those rooms, so my son's bedroom, my other, what will be a nursery bedroom, and my current office, being shown as studies and offices. Now, studies and offices have a design temperature of 21°C, so they'll be a little bit warmer. Now, 21°C, 18°C for the bedrooms, if you think they seem, on the cold side, you can get them to play around a little bit with the radiator sizes, but I wouldn't worry too much, because design temperature doesn't mean that is what it's going to hit. That's what it's targeted to hit as a bare minimum. Sometimes it will actually rise above that. So just bear in mind that if you are particularly of the cold person variety, you may be able to ask them to sort of overspec a radiator every now and again in certain rooms to hit a higher designed spec temperature. Now, before I mention I've got Microbore, luckily Aaron, the engineer that came round, is an engineer. He's not just a surveyor, he used to be a gas and plumbing engineer, and he's now turned surveyor for Octopus. So he really saw what pipes I had straight away. He knew they were Microbore, and he said because they're plastic, he knew they'd be 10mm, because they don't make an 8mm variety of plastic Microbore. They do in copper. So if you've got really small pipes and they're copper, there's a very small chance it's 8mm Microbore. Octopus currently can't do 8mm Microbore, but they can do 10mm Microbore, and obviously they can do every size larger than that. If you've got Microbore plastic pipes, he also explained that Octopus slightly over-engineer for Microbore pipes. They assumed that it would be fed to basically a big manifold where all the radiators would come out of one manifold. He says new builds don't tend to use this because they were prone to leaking and being stuck under the floorboards. They were a pain, so they tend to be 22mm feeds down my house and then tapped off into Microbores towards where the radiators are going. So that's more likely. So he said, based if my system was the 22mm and then tapped off, I would be able to run my system flow temperature a lot colder, which means I would get even higher efficiencies. So it would be over-engineered when it's put in with radiator sizes, etc., but then we'd be able to obviously lower that flow temperature later on and improve efficiencies, which might be an advantage to some people who've got Microbore pipes that know they're not on one of these manifold systems. Now, Microbore does cause one other major issue when it comes to radiators. Now, we'll get to the Microbore and radiator problem in a minute, but sticking with radiators for a minute, one thing that massively impressed me from Octopus is once we were done with the survey, he went round each room and explained which rooms needed new radiators. So we went in the new radiator rooms that would need adjustments to the radiators, so larger radiators. Now, what was nice is Aaron showed me on the tablet that he measured the space. He says this space could fit needs to fit a larger radiator. Would you prefer it to be longer and we'd extend the pipe work, or would you prefer it to just be taller and a little bit longer? So we had a little bit of playing. This really impressed me because it means aesthetically you can make a room look more pleasing. Now, with some options you might have to have a K3 radiator, which is basically 3 strips of heating panels and then obviously reflectors on the back. But you might not need this. You might just be able to make the radiator a little bit longer or a little bit taller. And I'd prefer that than having these big thick K3 radiators sticking out and encroaching in my room. Now, it was nice that Octopus do actually talk you through this and give you the option while the surveyor's there, rather than you're sort of like being left with a radiator getting installed on the day you're really unhappy with it. So make sure if you've got the engineer there and they are going to change some radiators, just get them to, make sure you're happy with what they're going to be changing them to. Now, one of the radiators in my home is almost 1,000 watts of heat. It's actually, I think, 850, 950 at the moment. It's very, very, very high wattage of heat output from that radiator. It's because it's heating my kitchen and dining room area. My kitchen doesn't have any rads. It's one rad in the kitchen diner that's to heat the whole large space in this room, which is huge space to heat. Now, the problem is that we can't make that radiator any bigger. If we make it any bigger, it would go over 1 kilowatt of heat output. And Microbore, according to Octopus's testing, and this is where we get the other problem with Microbore, can't carry more than 1 kilowatt of heat. So if we make the radiator bigger than 1 kilowatt, the room won't get warm because the radiator can't carry that amount of heat. And this is where we get into our first problem and also a hidden cost. We're going to have to put an extra radiator in the kitchen, which means I have to find an extra location to put that in. I do have a location in mind where I can put that in, which is just next to my boiler, just in front of where I feed my dog, which is fine. And the extra cost isn't the radiator. The extra cost we're going to discuss in a minute with some other hidden costs, because that's not the only one. When I spoke to Octopus on the phone to get a quote, they told me that if I wanted a tank in the loft, I'd have to pay for a structural survey out of my own money. That's not a hidden cost. But I thought when the engineer came, Aaron, we discussed maybe putting it downstairs and boxing off an area of my dining room Aaron actually advised that it probably would be quite a lot of space to be taken out. It would be bigger than I thought and would be quite a bit of a pain to put in where I was thinking. He said maybe I would be better in the loft, and he says because it's a new build house, it's what they call a trussle loft. Basically lots of splitters down in the loft the way it's built, and that their structural survey says it can take 200 litres in its current form. So 200 litres, he said, should be fine for the amount of people living in our house, plus if we had another addition to the family later on. So it should be able to be fine with 2 adults and 2 children living in the house with a 200 litre tank. But I said ideally I'd like a 250 litre tank. Sometimes I like to have a bath, and sometimes the wife likes to have extremely long showers. I mean really long showers. But let's move away from that for a second, because when we got into the loft, we found that we couldn't get a 250 litre tank even if I paid for the structural survey, because the loft hatch wasn't big enough to get a 250 litre tank up. That meant that I'd have to extend and enlarge the loft hatch. He had a quick look at where the loft hatch was and said, unfortunately, it's right between the rafters of the way the loft hatch is built. In other words, the loft hatch is perfectly centered in between all the rafters. So I'd have to cut away the rafters to extend the loft hatch, which means I'd need another structural survey for taking out that part of the structure of the loft. By the time I paid for all this, got it all done, it could be really expensive. I would advise that I might be better just to go for the 200 litre tank in the loft and maybe use a bit of heating to reheat the tank to a higher temperature, or if I had for the Cosy6, it would be able to sort of recycle that heat up the tank a little bit quicker if I was having long showers, was having lots of baths. But when we're up in the loft, Aaron dropped 2 bombshells on something that I wasn't aware that I'd have to pay for if I wanted a tank in the loft. And these are additional things that I have to get done, but also have to pay for. Now, my boiler is currently located in my kitchen, and my hot water tank is going in my loft, and my heat pump is going outside. This is a load of set of pipes that need to all get to the same location, which will be in the loft where the cylinder is. Now, the boiler at the moment in the kitchen is going to be coming out. There's going to be no boiler anymore. So the pipes are all fed to the boiler. So we need to get those pipes to the loft. Now that's going to be the hard part. We'll get to this in a second. The outside pipes are going to run up the wall of the house. There's some costs there, what we're going to mention in a second. But let's get back to the boiler. Now the boiler, they're going to lift the chipboard above my kitchen, which is where the boiler is, which is just about where my son's bedroom is upstairs, and they're going to then surface mount the pipework, 22mm pipework, up into the loft. Now this is where my problem is. I don't want the pipe surface mounted in my son's bedroom. 22mm pipe in my son's bedroom surface mounted, even boarded in later, would look an absolute mess. I'm in a new build house. I don't really want pipes or basically combing over the work with, boarding it out later. I want the pipes hidden in the walls and looking nice and neat. So I said to Octopus, what can we do about that? Unfortunately, they won't do it for free. What I'd have to do is I'd have to, before they came, cut out the wall, chisel out the wall, or I've got a studded wall in the middle. I could take the plaster off that studded wall and they will drill through that to bring the pipes up into the loft. Now that is the option that I will take. I'm going to let them do that and I'll make good afterwards. So the cost of taking the plaster out and then also replastering and repainting later, that's obviously a cost down to me. It's just a cost that you should be aware of if you want all the pipeworks hidden really neat inside the wall internally. Those costs are to you. That's up to you to get ready before they arrive. Otherwise, they'll just surface mount the pipework directly on the wall, which might not be ideal for everybody. Let's go back to the kitchen for a minute, because that's where some other pricing work is going to come in. Now, as I said, I need an additional radiator in there, and Octopus will quite happily provide that extra radiator and the pipework for it. The problem is, again, they're going to surface mount it because there's no radiator there, there's no pipework there. I don't want it surface mounted, I want it hidden away. So again, I'm going to have to chisel out the wall and make good after Octopus have gone. Now, because it's only Microbore pipe down to there, I won't have to take that much out of the wall to get it in, but it's still just a little bit of extra uproll that you might not be aware to, but it's not a cost that everyone's going to need. Now, talking about the loft, because we're going to get an extra cost up there. One thing I wasn't aware of is when it's going in the loft, you're going to have to board out the loft to make it safe for health and safety for the engineers to work up there. They're going to be spending most of their days up there. That's going to be the most amount of time that any of the heat pump engineers are going to spend is working on the tank. And they can't be asked to sort of stand between the rafters in your loft if you're having it in your loft. So you're going to have to board it out to make it safe for them to work on, safe for them to be up there. They're also going to need a light, so you're going to have an electrical light installed up there on a switch so they can turn it on and off when they're up there, but also have it boarded. Now, because I'm in a new build, it's full of insulation, full of it. There's loads of insulation in my loft. You can't squish it because that ruins the thermal properties of the insulation. So I could either get legs, so they could stand on the legs when they're working up in the loft doing the tank, or I could take the insulation away while they're working, board it, and then put the insulation back after they've gone. Those two options are both available to me. I haven't decided which way I'm doing it, but I will eventually work that one out. Now, it's also worth noting that I'm going to have, not only is that light going to have to be up there, that's going to cost me some additional money on top, but there is other options that Octopus have that aren't included in the standard quote. There's two paid options that Octopus will sell you. So all the other options so far, I've had to get people in to do, and I'll have to pay people to make good afterwards because Octopus won't do the work at all. But there's two options that Octopus do provide you with that you can pay Octopus to do when they're doing the heat pump install. Do you know what they are? Let me know down below in the description. Now let's first talk about what is included. Octopus install a heat pump. They'll put a heat pump in, they will put a cylinder in, they will change any radiators that need to be changed as part of the survey, and all the electric work that needs to go into putting the heat pump in. All that's included. Now let's face it, heat pumps are ugly looking things. They are not good looking pieces of furniture outside your house. You don't really want them on the front, ruining the front aesthetics. Now I have a two-fronted house. I'm on a corner, so I've got a front and I've got a side front. Both of these are viewable from the main public road, and I don't really want to ruin the aesthetics of my house too much. I also don't want it in the back garden. I've not got a particularly large back garden. I've not got a particularly large patio area, and basically I want that area for my son to play in, put toys and stuff like that, and I don't want a heat pump in there taking up the very limited space we have. There's also quite a lot of drainage hole covers, manhole covers in the back garden, which do mean it's not ideal. I can't fit it down the side of my house because basically it's too close to my neighbour, and there's a massive drop, so they also can't anchor it up, and I can't make any additional space down the side of the house because there's a house next to me. So the location I had in mind was down the side of a little runway that I own down the side of my house. We tried to think about putting it there, but there's a lot of things that I didn't realise you can't do with a heat pump, and some very large issues I wasn't aware of. Now, as the Cosy6 isn't out yet, we don't have the measurements, the spec, or any of the real details about it, so the surveyor had to do the survey based on it being a Dakin unit, which meant that we'd have to place this survey, act like this survey was for a Dakin, not the Cosy6, because we don't know the Cosy6 information yet. So if we can fit it for the Dakin, we can fit it for the Cosy6. So finding the heat pump location is tricky. Now, ideally, I wanted it down that side of that runway of my house, which is facing the public footpath. Now, I was explained to by the engineer that we couldn't have the Dakin unit there because it's too close to the public footpath. It needs to be 1 metre away at the moment under current planning legislation. This is due to change very soon. But he said the bigger problem with it being next to the public footpath there is it might be a public nuisance. And we explained what this meant by public nuisance, which is people could walk past the heat pump and the air coming out of the heat pump will be 7 degrees lower than the outside temperature, which means if it's 7 degrees outside, the air coming out the heat pump would be 0 degrees. So people might feel a bit chilly and I might get a lot of complaints. But the bigger issue here is because the fans are quite low in the decking unit, it could freeze the footpath on what would not be a cold, a day where it is freezing outside, that meaning that people could slip and I could get sued, and that means it's not ideal. Now we do think, we're pretty much not sure on this, but we're pretty sure that the Cosy6 fan is at the top at an angle pointing upwards, which means that I could actually fire it down towards my own property rather than towards the public footpath. So with the Cosy6 this wouldn't be an issue, but we can't be sure because the tech sheet isn't out yet. He doesn't know too much as an engineer about it yet because they haven't really released any of the tech or data sheets. It's not finished going through them all yet. So we had to find another location, and this is where you will definitely spend the most time with your heat pump engineer surveying where you're going to put the actual unit, because the next location, which seemed for me maybe impossible, might have actually been the most genius and best location we found until we found some more problems when we started measuring there. Now the last location is at the end of my garden. It's on the other side of my garden wall, so it'd be outside my garden. It's just a shrubbery area at the moment near where Laura parks her car, but it's a good distance from the house. I think it's over 10-15 meters from the house, which means there's a lot of pipe work to get from the end of my garden to my house and then up the house into the loft. Now it is probably one of the best locations. We can get it just about a meter away from the public footpath quite easily, but we will get into another problem that it did cause when we moved it a meter from the public location in a second. But let's just talk about this ideal location and one of the less ideal things about it, which means that the pipe work, originally if it was going on the first location, I had an internal part of the wall I could run it up with, which is where my soil flue pipe goes up. We were going to try and run it up there to hide the pipe work. We can't do that now, we've moved it to another location, so it's going to have to go up the outside of my house, which means I'm going to have piping go the outside of the house. Now Octopus will of course insulate these pipes as much as they can. That's brilliant for insulation, brilliant so it doesn't lose any heat loss from the heat pump. It's going to lose a bit, it's naturally, it's outside. The big problem is, aesthetically, pipes running up the outside of your house are going to look ugly. So I don't want ugly pipes running upside the side of the house, so I did ask, can Octopus duct it? And this is where we get into the first option that Octopus will actually sell you and do themselves when they do your heat pump engineer. And that is, you can pay for ducting. They only have one colour, which is black, which is fine for me, and I am more than happy to have black ducting running up the side of my house because my drain pipes are black. So my ideal location for the heat pump, if we moved it a metre away from the footpath, it was then going to be closer towards my neighbour's bedroom window. Now there's noise regulations and rules on heat pumps on how far they can be from the nearest habitable window. So we took some laser measurements from where the heat pump location would sit to my neighbour's window, put it into his tablet, and it worked out that the noise decibels would just be over what was required for the heat pump survey. If we moved it half a metre the other way, it was then within a metre of the public footpath but the sound levels would be far enough away from the window. So we're half a metre out one location or the other. We couldn't move it any other direction without being slightly out on either the sound or the public footpath rule. So we decided that what would be a best option is to move it 500 metres towards the public footpath. This fan would not be pointing towards the public, well, it'd be pointing diagonal away from the public footpath, so there'd be no new noise complaints, it wouldn't freeze the footpath, but more importantly, it's more likely to pass for being close to the footpath than it is to be close to a neighbour's window. So when it goes to a planning commission, those rules for 1 metre away from the public footpath are due to change. So the planning committee, the planning services should just pass it because they know it's going to be an allowed thing coming in the future. So there's no point trying to resist it. But however, moving it towards my neighbour's window, a nuisance noise is less likely to pass because there is other locations that I could possibly move my heat pump to, which are more ideal. So we're going with the public footpath being closer. Hopefully though, when the Cosy6 comes out, all these problems go away because the dimension and technical details and sound details on the heat pump will be completely different. But from this video, it is currently going to be a decking unit that we're installing for the survey. So it can have a decking unit, so therefore it will be able to have a Cosy6. Now another extra that they will ask you about is, do you want a hot water cylinder diverter? So obviously I'm going to have a hot water cylinder up there. I've got solar. Do I want to divert that solar energy? Now, he saw I had batteries. We took photos of the electrical loads and the batteries and the solar, so he knows everything is there. They ask you how you want the batteries to work. Do you want them to drain into the heat pump? Yes, I do, because it's saving me money. But they'll basically customize how they're going to do the design for you so it fits what you actually want. My advice is, if you've got batteries and solar, you want the batteries and solar to support the heat pump. It will reduce your bills. You can charge the batteries on off-peak energy anyway. You can store the power from the solar into the battery if there's excess, or you can use it to heat your home. But they ask you that, and they ask you if you want a Harvey. Basically, a Harvey is the My Energy device that diverts the solar energy into the storage tank. I don't want one of them because I have other ways and other ideas that I might do, and we might do something with My Energy systems, especially with now they're on Intelligent Octopus. I might have a word with My Energy if we can work on a video and a project around that. Now, more importantly, all this stuff, all this information, the survey, the floor plans, the radiators, the measurements, all this now has gone over to Octopus's team, and in about a week I will get a call and a detailed floor plan with all the radiator sizes sent to me, and as soon as I've done, there'll be another video on that. So if you don't want to miss that, go and click subscribe and click that notification bell. But more importantly, if you're wanting to learn more about heat pumps, check out this video I did about the fears I had about heat pumps. But also, if you're watching in the future, check out this video, which is the playlist containing all the stuff about heat pumps that I've done so far.